Hello friends, today we are going to discuss about Docker images. But you know what? Before diving into Docker images, let me tell you a very quick short story. This is Mr. John, the developer. He is working in a web application using technologies like .NET Core, MySQL database and many other dependent third-party softwares. Right now he is done with the development of the application and he wants to deploy it now. So what we usually do? We contact the ops team. So Mr. John also contacts the ops team. Can you imagine what kind of conversation both of them might have regarding the deployment of the application? It could be something like this. Ops team might ask, what is the application built on? You will say .NET Core. Next question, which version? 3.0. He might ask again, any databases are used? You will say yes, MySQL. Again, which version? Again, MySQL 2.0. Again, next question, any other dependencies to be installed? Could be multiple. Again, on those dependencies, might be a long list of questions. I think you're tired by even listening this, right? Yeah, that's really cumbersome. How about Mr. John telling this? This is my application bundled with all its dependencies. Take it and deploy it. That's awesome, right? Friends, that is where Docker image comes into picture. Though this is just one of the use cases where image can be useful, there are a lot many use cases where it can come really handy. So let's quickly see what we are going to do in this short video. We will quickly look into what are images again, how to push and pull an image to and from the Docker Hub, lots of Docker commands related to images, and finally, since without container images does not make any sense, so we will see how to run a container from an image. So let's get started. So what are images? The statement would not be wrong if I say in Docker everything is based on images. Images are the application bundled with all its dependencies. It basically includes the elements needed to run an application as a container. And what are the elements required to run the application? That could be operating system, development framework, databases, could be config files, environment variables, libraries, and many other things. Let me switch to my Windows command prompt. You can even use PowerShell, and if you are in Mac, use your terminal. Docker is all the same everywhere. Let's see if my Docker is running here. Docker-v. So it shows the version, it means it is running. Now there are many pre-built Docker images that you can just pull and use it without needing to define and configure your own. And where are those pre-built images? It's in Docker Hub. Let me show you that. Go to hub.docker.com. This is the repository for Docker images, just like GitHub, which is a repository for code. Let's go to Explore. These are all the available official images. You can see here MongoDB, Redis, Ubuntu, and lot many. Now let's switch to command prompt and pull one of them and understand what do I mean when I say just pull the image and use it. Let me first see if any images are there in my local Docker host. Yes, I have couple of images. This is my custom image, Ubuntu, couple of databases. For listing images, you can even write Docker images. Now let's see which image to pull. Let's pull one database. Let's pull this MySQL. Let's assume this. Let's say you have to work on an application and you have decided to use MySQL database. This is the command to pull this image. Let's go ahead and pull it to local. Let's list the images. So it is here. Let's run MySQL in a container. Docker run dash dash name dash e, that's for environment variable, MySQL root password. Now all this information you will find it in Docker Hub. You can see here it has already given how to run this image in a container, setting the root password and all. Let's give the password as Rygenix and then the image name. Okay, we have not given the name. Let's give it MySQL dash local. Let's enter. So our MySQL is running in a container. Now since this command prompt is already occupied with MySQL container, as we have not run it in a detached mode, let's open another command prompt. Let's see if our MySQL is running in a container. So it is running. Now let's go inside this MySQL container and let's write few SQL queries, just to demonstrate that it just works like a normal MySQL installed in your laptop. For that, just use docker execute command. Docker execute. Let's run it in an interactive mode. Let's name the container as mysql-local and let's bash it. Now we are in our MySQL container. Let's run MySQL command in this container. This container has MySQL, so we can definitely do that. MySQL, you have to log in. So -u, the default user is root and the password -p. Let's give the password as Rygenix and enter. So you are in the MySQL terminal now and ready to use all your MySQL database commands. Let's create a database here. Create database. Let's name it as studentdb. Let's use the database. Let's create a table inside this database. Create table student. Let's create two columns, id, int, not null, and name. So our table is created. Let's insert a data. Insert into student, id, name, and the values. So the data is inserted to our newly created table. Let's see whether the data is available. Select star from student. See, the inserted data is available here. So I hope you have realized the power of Docker image. You just need Docker in your system and nothing else. Now with this MySQL, you can connect your .NET or Java application and work. Now let's see most of the commands related to Docker image. So here we will see how to list an image, how to list only few selected columns for all your images, how to inspect it, how to see the history of the image, how to remove a particular image and multiple images at once, and finally how to modify any existing image and tag it to a new version. So let's get started. Let me exit from MySQL. Let me exit from the container as well. So by now you already know how to list the image. Docker image ls. Let me remove this Rygenix image. The name is quite long and occupies a lot of column space. Now let's see how can you format the listing of your image list. Docker image ls dash dash format. Using format option, you can display the images in certain declared template. Let's give the column name that you want to display. It has to be given inside two curly bracket dot id. Put a separator as comma and another column dot repository. This command will display only the ID and repository of all your local images without headers. So you can see the image ID and the repository names are displayed. The ID and repository are separated by comma. You can use any other separator like colon or semicolon as well. Let's do that. See, now the separator is semicolon. If you want to display the info with the headers, then just write table here and slash t for a tab, and let's print tag as well. See, now you get the header as well. You can find out all the options in the Docker docs. Let's see that. Go to docs.docker.com, reference, command line reference, Docker CLI, and then images. And down here somewhere you should see format option. Yes, it's here. So these are all the options that you can use. Now let's move to our next command. Let's see how can we see the history of the image. Docker image history. Give the image name. Let's see the history of MySQL. So this is the history of MySQL image. It shows the image ID, how many days before created by which command, etc. You can again format the output. Say you want to see only the ID and when the image was created. Let's see that. So now it displays the image ID and how many days before created. Let's see our next command, inspect. Docker image inspect, image name. Let's inspect again MySQL. You can see it displays some JSON kind of info where you have lot of key value pairs. You get the info like repo name, container ID, host name, exposed port, the environment variables, commands, even the different layers of the image. Let's move to our next command, removing images. Let's remove this Nginx image. Remove single image, Docker, RMI. RMI stands for remove image, and then the image name, Nginx. You can even give the few characters of the image ID, just enough characters so that Docker engine can identify it as unique. So, image got deleted. Let's verify. You can see Nginx is not there now. Let's see how can we remove multiple images at once. Docker image rm. Let's remove Postgres and MongoDB as well. Let's verify. So both got deleted. Now let's try to remove an image which is already running in a container. Let's remove MySQL. Remember, we ran this image earlier. Since the image is running in a container, we should not be able to remove it. See, we get an error here which says unable to remove MySQL, must force container 31D is using the referenced image. Let's force the remove. How do we do it? Use -f flag. But guess what? Still there is no deleted message as such, right? It says untagged, which means the image is untagged now. So the image name and tag will not be available. See, the repository and tag is not available. Since at present the image is running in a container, it did not delete it completely. Makes sense, right? The container might be doing something at this moment and deleting it might impact. If the container would have been stopped, then it would have untagged and removed it as well. I'll explain regarding removing containers and all in my next video on container. For now, let me stop the container and delete this untagged image. So we do not have the MySQL image now. Now let's do a tagging of an existing image. Tagging basically conveys useful information about the specific image version or variant. It means you pull an image, make some changes to it, and tag it with a different name and push it to the Docker Hub as a new version with new tag. Let's run Ubuntu in interactive mode. -D so that it runs in detached mode. Let's see if our container is running. So our Ubuntu is running. Let's go inside this container. So we are now inside Ubuntu. Let's list all its folders. Now let's create a folder. Mac directory, temp folder. Let's list it. So temp folder is here. Let's exit from this bash. So let's see if our container is still running. Yes, it is running. Let's go inside again and check if our folder is there. Yes, it is there. Let's come out. Now let's create a new tag. How do we do that? Just type docker commit your container ID and new name with a tag. That's kind of version. Let's see if the tag is created. So that's here. Let's push this to Docker Hub. Docker push. Let's try giving image ID. Guess what? That did not work. This is because we have a tag and we have to specify tag. Let's give the image name with tag. Okay, it says the access denied. Looks like I have to log in. Let me do that. Docker login. Username is Docker for teaching. Password. I hope I remember. Looks like that's wrong. Let me try again. Thank God, login succeeded. Let me push it now. So, push started. So, pushing is complete. Let's go to the Docker Hub and verify. Yes, it's here. So this is a new Ubuntu image tagged by me. Remember, it has a folder called temp folder. Let's quickly pull this image now to local. Let's remove the existing image first. So the Rygenix Ubuntu is not available. Let me pull it from the Docker Hub. So it's there now. Let's run it. Let's list the folder. See, you still have the folder. So to summarize tagging, you can always take an existing image, run it in a container, make changes according to your need, and then you can tag it with a new name, just like a new version of that image. That's all I have today for the image. We will definitely cover a few miss out topics in our upcoming videos. I hope this was informative. Please do comment and let me know. For all my upcoming videos, do subscribe the channel. Thanks.